From birth, we embark on a journey of growth, transforming from fragile infants to capable adults. This journey is marked by countless milestones, each representing a step towards maturity. Every phase of life brings its own unique challenges and triumphs. Cells divide and multiply, orchestrated by genes passed down through generations. This genetic blueprint is the foundation of our development, guiding us through each stage of life. Childhood is a marvel of boundless energy and rapid learning. It's a time when curiosity knows no bounds, and every experience shapes our future selves. The lessons learned and the memories made during these years are crucial for our personal growth. Yet even in youth, the seeds of aging are sown. These early signs are often subtle, barely noticeable, but they are there, quietly marking the passage of time. Aging is a gradual process, like summer fading into autumn. Each season brings its own changes, slowly but surely, altering our bodies and minds in ways we might not immediately perceive. Our cells accumulate damage from environmental toxins, metabolism, and even breathing. These factors contribute to the wear and tear of our bodies over time, gradually affecting our overall health. While our bodies repair themselves, they can't escape time's relentless march. The self-repair mechanisms slow down as we age, making it harder to recover from injuries and illnesses. To understand aging, we must delve into the intricate workings of our cells. It's a complex process that science continues to explore, revealing new insights every day. These discoveries help us better understand how to maintain our health and vitality as we grow older. Imagine a bustling factory, filled with the hum of machines working tirelessly day in and day out. Over time, these machines eventually wear out and break down, no longer able to perform their tasks efficiently. Our cells, much like these factory machines, decline in function as we age, losing their efficiency and vitality. This gradual process, known as cellular senescence, is a natural and inevitable part of aging, affecting every living organism. Senescent cells linger in our bodies, secreting harmful molecules that promote inflammation and tissue damage, disrupting normal function. Think of them as retired workers who not only stop contributing, but also discourage the younger ones from working efficiently, creating a toxic environment. This accumulation of senescent cells significantly contributes to age-related diseases, including cancer, heart disease, and other chronic conditions. Understanding the mechanisms behind cellular senescence is crucial for promoting healthy aging and longevity, potentially transforming our approach to healthcare. Scientists are actively researching and developing interventions to target these cells, aiming to extend our lifespans and improve quality of life, offering hope for the future. Deep within each cell's nucleus lies our DNA, organized into chromosomes. At the ends of chromosomes are protective caps called telomeres. Telomeres prevent chromosomes from damage during cell division. Each cell division shortens telomeres slightly. Critically short telomeres cause cells to stop dividing and enter senescence. Telomere length acts as a molecular clock, measuring biological age. Shorter telomeres increase the risk of age-related diseases. Lifestyle factors like exercise and a healthy diet help preserve telomere length. Imagine a book with pages that become torn and faded over time. Each page tells a story, but as the years go by, the wear and tear become more evident. The once crisp and clear text becomes harder to read, and the pages become fragile. Similarly, our DNA accumulates damage from UV radiation, toxins, and metabolism. These factors continuously assault our genetic material, causing it to degrade. The integrity of our DNA is compromised, leading to potential health issues. Cells constantly repair DNA, but efficiency declines with age. Over time, the repair mechanisms become less effective, leading to more persistent damage. This decline in repair efficiency is a natural part of the aging process. Think of aging librarians repairing damaged books less effectively. Their once nimble fingers now struggle to mend the fragile pages. The tools they once used with precision now feel cumbersome and inadequate. Accumulated DNA damage disrupts cellular function, leading to cell death or cancer. This ongoing damage can have serious consequences for our health. It can affect the way our cells grow, divide, and function. Understanding DNA damage and repair is crucial for preventing age-related diseases. Researchers are dedicated to uncovering the mysteries of our genetic code. They aim to find ways to enhance our natural repair mechanisms. Scientists aim to develop strategies to promote healthy aging. Their goal is to find ways to enhance the body's natural repair processes. By doing so, they hope to extend the healthy years of our lives. Our DNA, the blueprint of life, can accumulate damage over a lifetime. This gradual accumulation can lead to various health issues. The longer we live, the more damage our DNA sustains. This damage can arise from various sources: exposure to ultraviolet radiation from the sun, environmental toxins, and even the byproducts of our own metabolism. Each source contributes to the gradual decline in our DNA's integrity. Understanding these sources is key to developing preventive measures. Within each cell are tiny powerhouses called mitochondria. Mitochondria produce ATP, the energy currency of life. As we age, mitochondrial efficiency declines, leading to muscle weakness and fatigue. Factors like oxidative stress and genetic mutations contribute to dysfunction. Scientists are investigating ways to protect and improve mitochondrial function. Imagine a city powered by aging power plants, leading to power outages. Similarly, declining mitochondria impact our health and contribute to age-related diseases. Proteins are the workhorses of our cells, essential for life. Our bodies constantly synthesize new proteins and degrade old ones. This balance, called proteostasis, is crucial for cellular health. Aging disrupts proteostasis, leading to misfolded proteins and toxic aggregates. These aggregates are implicated in diseases like Alzheimer's and Parkinson's. A healthy lifestyle supports proteostasis and reduces disease risk. Scientists are exploring therapies targeting protein aggregation to combat aging. In conclusion, the science of aging is a complex and multifaceted field. Understanding how and why we age can help us make informed decisions about our health and longevity. Thank you for watching.